Friends, so today we gonna discuss this question from LeetCode challenge problem. Check if a string is a valid sequence from root to leaf path in a binary tree. You are given a binary tree where each path going from the root to any leaf forms a valid sequence. Check if a given string is valid sequence in such a binary tree. So what the question actually states that you are given a binary tree and a sequence. You have to check whether this sequence is a path from the root to any leaf. So as you can see, this is a path from this top root to this leaf. So this is true. But this is also a binary tree, but this is not a valid path from the root to any leaf because the value doesn't match. And even if there can be a path such that the value match, but it doesn't reach the leaf. So both of them return false. So you just have to tell whether there is the sequence which goes from root to leaf. Okay. So what's the simple way is we start at the root node. We check whether the first index is this value or not. If it's this value, then we have to check whether it's both children, any of them returns has 0 or not. If it's 0, it's good, we keep going. Else we return false from it. It means, yeah, this is not a valid path. So at any point, if it doesn't match our answer, we return false. Okay, but when do we terminate? Which is our base case? Our base case is when we are at the last point of our sequence and it is also the leaf node and the value also matches. So when we are traversing through the sequence one by one, so we started here, then we increment our index value and check whether this is equal to this. Yes, so we move here, this is also equal and this is also equal. So at the last point, at any node, we check whether we are at the last sequence which we want to check, and this is also a leaf node. Then and the value also matches. If all these three conditions matches, yeah, we are good to go, and we return true from it. And if any of the leaf node return true, we have a valid path. So we can directly jump to the code if you understand the logic, and it will be more clear from the code. Okay, so what we can do is we will first like store the length of the array, and we will store the answer and call a DFS in which we will send the root, the array, the starting index of this array, and what is the length of this array, and we will return answer. Okay, then we have to call or make a DFS function which takes the tree node, root, also it takes a vector of array and we pass its address ARR. Then we make an index which stores at which index of the array we are at and the total length of the array. Okay, so if the root become null, we just return false, which means we doesn't care at that point. Okay, so now our base condition is if index become n minus 1, which means we are at the last point of this array, and if the root is a leaf node, which means its left child is null and the root right child is also null, and the value at this point, the root value is equal to array at that index, then only we return false, then only we return true, I'm sorry. Okay, but else if what we check is that our index is less than n, which means we are not at the last point, and the root value is equal to the array value, which means we are not at the leaf node but our value matches at the given node. So we have to return the DFS on both the childs and do OR of it. It means if any of the child returns true, it means it has reached the leaf node. In which we passes the address of the left child array. We increment the index because we have matched this index and the length, or DFS of root of right AR index plus 1 and other than these cases we just have to return false. And let's try this. That's true. Let's submit it. So it's accepted. I hope you understand the logic. If you still have any doubts, please mention down. Thank you for watching this video. I'll see you in the next one. Bye.